All right, so I'm going to officially open it up to anything. You can talk about the practice, this, whatever. Somebody did remind me that we did this problem here, but we got to the point where we realized we couldn't do it. So I'm going to leave it up to you guys. We could just do this right now, which I would highly recommend, because it's kind of like that idea. It's easier to review if you kind of go backwards. Is that cool with everybody, or does anyone have a burning question, especially if you're going to leave at like, I don't know, 12:30 or something? Anybody have a burning question that they want answered? So let's try this problem. Do you guys remember this problem? We only knew the disk method at this point, and we tried to set it up and we realized it wouldn't work. Not easily anyway. So let's remember what's going on here. I've got my little region here, and I'm going to rotate around the x-axis. But my function's in terms of y, and I can't easily solve for y. Because what would disks need from me? Yeah, it's around the x-axis, so disks would need dx, and that's exactly what I don't want to do, right? So let me kind of start this problem from scratch, because this little graph is a little too small. So we figured out the y-intercepts were 0 and 2, and then I think we plugged a 1 in, and we got 1. So then we got this region here. Almost done. Okay, so that's this problem blown up a bit. So this is 2y minus y squared. And I'm rotating around the x-axis. So this is a really good, I like that you remember this, because this is an example of a type of rectangle that's doing something different than we've seen. Does everybody understand why I don't want to do disks for this problem? We talked about it before. So I want to use shells. So what would shells need? Integral dy. Yes, integral dy for shells. So then I need to figure out r and h and a and b. A and b are easy. What are a and b? 0 to 2. That's where my region lives along the y-axis. Everything is happening from y equals 0 to y equals 2. Everything's there. Okay. Draw in a representative rectangle, but what's it going to look like? Is it going to be standing up or laying down? It's going to be laying down, because it's got to be parallel to the axis I'm rotating around. So it's going to be laying down. Just put it somewhere. So where's my center? I feel like a yoga instructor. Everybody find your center. Where's your center? Where's the center? The what? X-axis. So what's the radius then? Where's this rectangle? Did I have to put it here? I could have put it there. I could have put it there. So what's the value where the rectangle is? Y. So what is the radius? From the center to the rectangle is how far? Y. Holy shit. Okay, so the radius is y. My rectangle is laying down, correct? So my height is a height, like, just if I lay down, it doesn't mean I'm suddenly 2 foot tall. Still the same height. So my height is going to be how tall this is, and it starts at 0 and it goes to the function. So of course, how tall is it? X. Which is 2y minus y squared. Yeah. So the height is 2y minus y squared. And I'll tell you this, considering we had to shove this in right at the end of the semester on the test, I'm not going to tell you which method to use, but I will give you the general format for both methods. Yes. So if you know you're using shells, you completely focus on what's the radius, what's the height, and what's a and b, because that's what I need to do the integral. Yes? Yeah, like this, 2 pi RH, right? I would put that on there. Unless you don't want me to. I don't have to. Yeah, I'll like do something then. Okay. So this will be, what's the integral going to be then? Integral from 0 to 2. Got my 2 pi out front. R is y. And h is
2y minus y squared.
There you go. Maybe some of you guys realize why I like shells. And one reason why we start with discs is because shells is really nice and get the hard part done first. Yes? How do you always figure out the radius? You start at the center, the axis, the center. And you draw till, for discs, you draw until you hit a wall. For shells, you draw until you hit your rectangle. So I put my rectangle here. Where is it? It's at some y value. How far away from the center is that? Y. Cool. So 2 pi 2y squared minus y cubed. This one's relatively quick, yes? In case you're like, this guy never finishes anything. What's wrong with this guy? How do you integrate that? 2/3 y cubed minus 1/4 y to the 4th from 0 to 2. 2 pi, let's see, it'll be 2/3 times 8. Yes, putting a 2 in. 2 to the 4th is 16 divided by 4 is 4. And when I put a 0 in, I get nothing, yes? So I end up with 16/3 minus 4, which is 4/3, which makes it 8 pi over 3, is that right? What did we get the first? No, we didn't do it this right, because we couldn't. Duh. Me, I'm smart. Okay. Is that alright? I kind of did the end a little fast, but that's because it's just, antiderivative and then shove stuff in. But you asked the good questions. I mean, how do you get the radius? It's always start at the center and go out. For discs, you go until you hit a wall. For shells, you go until you hit your rectangle that you drew. Yes?
Why is it 2 pi?
Oh, because we built it based on the circumference. If I chop it and open it, circumference is 2 pi r, yes? Why is it 2 pi r? Because it is. We built it, I got this song, we built this city on Rock Road. We built it from the surface area of a cylinder, which is 2 pi r times h times the thickness.
So it's only 2 pi because it's cylinder?
Yes. Just like, what is the main thing with discs? Isn't it pi r squared? Why is it pi r squared? Because we built it from areas of circles. That's another thing I love about these, is you can always go right back to discs are built off of circles, so it's pi r squared. These are built off of cylinder surface areas, which is not something we know as quickly, but that's why it's not squared. Well, because it's r times h, so it's not r times r, like circle is pi r squared, this is 2 pi r h.
So it kind of still look like a rectangular cube. It's just your other side is dx, and dx is infinitely small.
Oh, yeah, you could actually unfold like a slab of it. Are you talking about like I could put a little dx here? Yes.
Yeah, that would be
Yeah,
the dimension.
exactly. Yeah. So, if I put the thickness here, now it's a volume. This is dx. The volume would be 2 pi r times h times dx. Yeah. Okay. So now it's up to you guys. Yes. Which one? 5i. I also have to remember that there are several on here I didn't put on the practice answer key. Oh yeah. This one's kind of nice because it's exactly the same format as the problem we did together. What sucks about the bottom of this fraction?
There's 2 numbers.
Yeah, it's two numbers. I wish it was just one thing, then I could break it up. So how do I make it one thing? I replace it with one thing. Yeah. I use use of. Now, you could long divide if you wanted to. And if you do, shed a little tear for you. Out of happiness and concern. But let's try this out. If I let u equal 2 minus 3x, what's du? What is it? Negative 3
U.
dx.
Are we missing a variable?
What do you mean?
Like the 3x. So, oh no, or we can just add a negative.
You ready for this? If I solve this for 3x, isn't it 3x equals 2 minus u? Yes? So 3x is 2 minus u. 2 minus 3x is u. And then, don't I need this to show, is everybody semi with me? That was the trick. That was the next phase of u sub. If I say u equals stuff with x, I could solve for x and see what x is in terms of u. And then that could be useful. You see, I solved for 3x because I'm clever, boy. I got a 3x up top. If I solve for 3x, I know what to shove in there. 2 minus u. Do I have what I need for my du though? I got my 3x replaced. I got my 2 minus 3x replaced. My poor little dx is missing what?
Negative.
-3. So what am I going to multiply by on the outside so I can multiply by a -3 on the inside? If I put a -3 here, on the outside I better put -1/3. So now this is du. Now I've shown this to students before and they're like, what the hell, I still got a stupid fraction, Jeff. No. 2 over u minus 1. Easy, yes? Now you could long divide, and it works beautifully. It's a little bit tricky if you do it that way.
You okay with us doing it that way?
Yeah, of course. Yeah,
So we did have a test, you would mark us
Nope.
down.
I would not, as long as you show me the way. Yes. If the 3x wasn't there, is that what you're saying? I'm not sure what you mean. I don't know. Are you saying if the 3 wasn't there? Okay. Good. So, are you asking why I did this? Okay. Yeah. So I have this guy covered, I just don't have this guy covered, right? Because the du is not x dx. It's a constant times dx. So I currently have no way to take care of this guy. And then I go, oh yeah, I could just solve this for, I could solve it, in general you solve it for x. But on this one, you could be a little smart and go, let me just solve it for 3x's, that's actually what's there. And then I can just directly replace it with 2 minus u. Yeah. Yes?
So because we now switched it to terms of u, do we have to substitute the x's back in?
Hell no. Not right now. Eventually, yes. You would not put it back in right now because then you would defeat the whole purpose. What am I going to do immediately now after I break it up?
Integrate?
Integrate. And then I put back in what u is. Yeah? Okay. Oh yeah, I forgot about that. That's By the by, did I even say it here? I didn't even say it here. There. All right, look. There's a section in chapter 6. It's the very last section. 6.5, I think. It's finding the average value. How do you find the average of a bunch of numbers?
You add them together and then divide by the number.
Yeah. So how do I find the average value of a function? I add them all up. Alright, that's integral. Integral is adding them up, yes. And the divide by would be divide by how wide it is. That's all that section says. So whatever that section is, don't even worry about doing it. Sure. Extra credit. Why not? Because it's easy as shit. You have to know how to integrate, don't you? All that last section says is integrate it and then divide by, if your interval's 1 to 8, you're gonna divide by 7. Ooh, so it's kind of stupid, it's kind of silly. Maybe? No? Screw you, Jeff? Okay. So, oh,
Sorry, do you want me to turn it over for 6.5?
whatever that last section is, I think it's 6.5, yeah.
But it's gonna be on the exam.
That would be so evil. No. I might put a bonus question, but I'm probably not gonna remember.
So 6.5 is.
I think it's 6.5, right? You guys have your homework sheet right there?
It's 6.
Is that
It's 6.5.
6.5?
Yeah.
6.5.
Do you put the bonus questions in your final?
I do. There will be about 4 bonus questions on the final. So you could make 108 on the final. Alright. I did not do the last 3 problems in number 8. Because I ran out of room, I didn't feel like using another sheet of paper. So if you want to, we could do D, E, and F right now. Or at some point. We might be a little fatigued on rotating stuff, so maybe we do some other questions first. Does anyone have any other things you want to focus on? Yes.
And then it would be
2? 57, okay. Do. What's this page? 366. Why don't you take your glasses off, John? 57. Oh yeah. All right. This one is kind of funny because it's way easier than you might think, which sometimes makes it really hard. So what's the hardest part about optimization problems?
just tell me what's telling them.
Sure, but that's not. I hope that's not. To me, it's setting up the formula. Yeah. They gave me a formula in number 57, right? They gave it to me. I didn't have to set it up. I didn't have to go out and become an oceanographist. Is that what you say? Oceanographist. Oceanographer. There you go. I know English. Okay. So this one gave me a function already. K and C are constants, yes? How do I find the L that makes V a minimum? How do I find the minimum of a function? Take the derivative and then the second derivative. If you feel like it, sure. Take the derivative and then immediately find what from that? Critical numbers, which are the what's that what?
When 0.
The values that make it 0 or undefined. So I need you to understand, 57 is an optimization problem, but it's already done the hardest part for you. It gave us the function. Now, what's my variable? V is a variable, correct? What's the other variable? L. So I would rewrite the inside as 1 over C times L plus C times L to the negative 1. Or it doesn't really matter because that would make it easier to take the derivative eventually. So you have to take that guy's derivative. It's a little gross because it's stuck inside of a radical, yes? But the K is a constant, so it's not a product rule, yes, no. Is that, no? It's all my answer. But, so, here's how I would write it before I try to take its derivative. I would write it as Jeff. I would write it as K times 1 over C times L plus CL to the negative 1 to the 1/2 power. Those are the same thing. 1 over C times L plus CL to the negative 1, all to the 1/2 power. Now the derivative, it's in the right forms for me to apply the derivative easy. 1 over C is a constant, correct? Okay. Yes.
So one over C also be LC to the negative one.
Sure, but I need you to understand why you don't have to do that shit because C is a constant. What's the derivative of 1/3 x? 1/3. What's the derivative of 1 over CL? 1 over C. Why do I want to write the L to the -1 then? Because it's the variable. Now it's in the form variable to a constant power, then I can apply that rule. Yes? Okay. So short answer, sure, you could write it like that. Longer answer, but it wouldn't help you. Now, everybody sees a chain rule too, right? You have to bring the 1/2 power down first and blah, blah, blah. Yeah, you should know. Alright, anything, what else you want to talk about? We could talk about stuff from the quiz, stuff from the practice test, stuff from homework. You could even just say, man, that optimization shit, what's that all about? Maybe don't say it like that. Or we could stare at each other.
Are there no problems on here about, stuff we just did?
Oh, no, they're in there. That's the ones I just pointed out.
Oh, 8.
Yes.
Can we just do that, like last time?
Sure, let's do it. I told you I'd have to do it at some point because I didn't put it on the answer sheet. So, do you guys see how D, E, and F are all the more recent stuff? Because I'm rotating and I'm asking to find volume, right? Now, I think I did D to a certain point. Can you guys, if you haven't tried yet, can you try to set up D? I feel like I'm watching a really boring movie. Sorry. Just to make sure everybody's got what's going on. Jumping in on D is a little difficult because what you would have done before that, part B is important, yes? To be able to do part D, you should be doing part B. And you should be trying to graph it, yes? Okay. Sure. Is everybody got this here? This plain along? So now at -2, This is at 4 plus 6 plus 6, 16. So this should also be, so if I do it again, I get 2 times 4 is 8, plus 6 is 14, plus 2 is 16. So they both meet at 16 at -2. And at 2, this is at 4 minus 6 plus 6 is at 4. So just to make sure, 2 times 4 is 8, minus 6 is 2 plus 2 is 4. So they both meet at 4. Of course they do, because we force them equal to each other, so of course they equal each other. Now what sucks a little bit about this is both of these parabolas, how are they opening? Up. When one opens down and one opens up, it makes a nice little region like this, yes? Oh, look at him. Oh. This, how the shit do I draw these? They both open up, so what do I do to get these drawings? What's something I can do to help me? You can do it.
Find their vertex.
Nah, I wouldn't do that. No, sir. Don't waste your time with that. Just plug in 0. Does everybody agree with me that if you plug in any point in between here, whatever's on top and on the bottom will remain that way throughout? What's the only way one function can go and become the bottom function when it was the top? If I have a top function, what's the only way it can become a bottom function if it does what? The two functions have to do what? If I have one function that's on top and the other function is on the bottom, what's the only way they can switch? If they intersect. And where's the only places they intersect? Here and here, yes? So I can pick whatever. I'm gonna pick frickin' 0 because it's smart to pick 0. What's the output here for 0? 2. So at 0, this is at 2. What's the output for this guy? 6. So let's see, let's keep this really clear. This one is, what was this guy again? G of x. And this one, good Lord, Jeff, little banana, is f of x. Do you guys see what I mean? What is important in basically all of chapter 6 is which function's on the top, which function's on the bottom. Oh, we're not doing part A, we're doing part D. Yeah. Part A is just integrate G from 2 to 4.
Oh.
Yeah, that's on the answer key. This one's not on the answer key. So has everybody got their little banana? And I accidentally drew like a little line in there. It actually works, so it looks like a little banana. That's awesome. Okay. Now what? What am I rotating around for part D?
The x-axis.
What?
The x-axis.
Blah, 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 blah. The x-axis, yes. So if I want to use disks, it would be integral dx. Love it. And I'm going to stop there. That's what I want, yes? I don't want to solve those for x. I want to leave them as functions of x, correct? Do you guys see how to just write down what disks we need and step back? Does that work? Yes? Do it. Does it work? No? Don't do it. Do shows. Do you guys get that? Because it's understandable. The hardest part about mathematics is when do I do this thing? Right? I understand how to do it. When do I do it? That's the big deal. So I've got my center, my axis. We know we're going to do disks. So now I completely focus on radius. Will I have to get 2 radii here?
Yeah.
Why do I know that?
Because it's not hugging the x-axis.
Oh, it's not hugging. It makes me a little cry, a little tears when somebody uses the weird ass words I use. But it just makes sense to me. It's not hugging it, so there must be an inner and outer. So how do I figure out the inner radius?
You start from the...
Start from the axis. Draw till you hit something. So what's my inner radius?
G of x.
G. And then of course my outer radius. You're not going to believe it. It's F. I think I do think I put this much on the answer key, but then I didn't do it. I'm not going to do it here either because let's set this up. What would the volume be? How do I set this up for disks? Pi. What am I going from to?
-2 to 2.
Yes, dx. So I don't care about what x is doing. X is going from -2 to 2. That's how I can scan my banana. -2 to 2, I scan my whole banana. That's what this is. And then what goes on the inside? Yes, r outside squared, which will be, what was the f again? There it is. X squared minus 3x plus 6 squared minus our inner squared. Alright, and I apologize, because I'm not going to give you a problem that involves this much busy work. You guys see how much busy work that is? You have to multiply out to an x, that times its own, twice, If you had to, could you sit there and do it? Would the interval be hard after you multiply that shit out? No, you're gonna get a polynomial. What is one of the easiest, I don't care what kind of polynomial it is, if I give you a polynomial to integrate, you say, wow, this guy was in a good mood when he put this together. See how I'm feeling when I create this test. Okay. Is that cool? I'm not even gonna do any of those. Is that alright? You guys cool? That's the hard part. Now this is busy work, but it's not hard. Write this twice, FOIL it out, put your like terms together, antiderivative. Is that alright, you guys? Alright, so let's do E. E is using the exact same region. So let me sketch it out real quick. But I'm rotating it around x equals -2. What would disks need from me? It would need interval dy. And we already said we don't want that shit. So we're not going to do disks. Because I have this whole other method. So we want to use shells. Because shells will allow me to do dx. Yes? Disks would need dy, because disks are always d thing you're parallel to. I'm parallel to the y-axis, so this would be dy. I can't solve my function for x. I could, but I don't want to. So now I totally focus all my attention on question. What? What do I draw?
A rectangle.
A representative rectangle. Yes. Have a little election. Pick the rectangle you're going to send to Congress. You can put it wherever the shit you want to. I'm going to put mine over here because I haven't put one over here yet. Why did I draw it that way? Damn it, Jeff. Sorry. Why did I draw it that way? Because I want it parallel to the line I'm rotating around. So this time I want it standing up. Yes. You guys get that? That choice is huge because it's going to totally affect kind of like the walls I'm going between. Maybe you guys get it. What can I put underneath my rectangle? X. Good. So what's the radius? Now, did any of you guys put it over here? It doesn't matter. Where do I start? To figure out the radius, where do I start? Where? The thing I'm spinning around. Thank you. So I start at -2 and I go to x. Even if you put it over here, you're going to go to x. So how far apart are those? X plus 2. Let's check it. What if x is -1? If x is -1, this should be 1 apart, correct? What's -1 plus 2? 1. So you can always physically check to make sure what you wrote makes sense. Yes? Okay. What else do I have to figure out?
The height.
The height. So how tall is this rectangle we drew here? How tall is it? hands are like, that's about a quarter of an inch tall, Jeff? I don't know, the projector makes all the scale freaky.
Is it G minus F?
Yeah, it'll be the top minus the bottom, so, well, be careful, it'll be
F minus
F minus G. Do you guys get that? Do you guys start to see how discs were all like, ooh, it's not hugging, I need an inner and an outer. Whereas shells are just like, I'm just gonna draw my rectangle and not even worry about the empty spot, you dumbass discs. That's why I love shells. Shells are like, oh, there's a gap. Let's just not count it in the first place. I'm not sure if you guys are all with me. So now we put together, I'm still gonna go from what to what?
-2.
-2 to 2. R is x plus 2. H is F minus G, which will end up being, shit, which was what you get?
X squared minus 3x plus 6.
Yeah, it'll end up being negative x squared plus 4. If you actually subtract the 2, you guys with me? Now you FOIL and integrate, it's just a polynomial, so. Is that okay? Let's stop there. Is anybody concerned? Like, why doesn't this guy finish anything? We're gonna get that later, someone's gonna say, this guy didn't finish anything.
Did you take out a 2?
What did I do?
Get the negative x squared plus 4.
Take your f function and subtract your g function.
Yeah, but then you get negative 2x squared minus 4. X squared minus
What's x squared minus 2x squared?
negative 2x squared.
No, what's x squared minus 2x squared? What's 1x squared minus 2x squares?
Oh, it's minus 2x.
Negative 1x squared, yeah? Okay. Sorry, I didn't mean to call you out. Alright, and was there a part F? Jeff, what the shit? Alright, so if I go y equals -1, oh, this is really the one you don't want to do. So if I rotate around y equals -1, I'm going to use discs again. Why am I going to use discs?
Because we have dx.
Dx, it would allow for me to be integral dx. The only thing that's going to change from what we did earlier here is if I go around -1, what's the inner radius? It's going to be g plus
Plus 1.
plus 1. So I would have a +1 in both of these. So this would be 7 and this would be 3. Do you guys see that? Both of my radii will be 1 bigger than they used to be. So I would have a 7 there and a 3 there. And then I basically do all the same work. So I got you twice with the busy work. I love it. Yes. If there was a, yeah, it would work the same way. Oh, like if you had a sine, yeah, then it would be sine squared.
So it's shells can be used when it's parallel, and disc can be used when it's perpendicular.
When what's perpendicular? When what's
Where
perpendicular?
like your boxes on.
Oh, no, you're thinking about it backwards. If I'm using shells, my rectangle has to be parallel to the axis. It doesn't tell me I'm gonna use shells. It's if I'm using shells, that's what I have to draw. The rectangle doesn't exist until I've chosen shells.
Yeah.
Okay. Hopefully that answers your question. Yes.
But isn't it rotating around the x-axis? So then how is your box parallel to the x-axis?
Where are we
Isn't
at?
it
Sorry?
moving?
Which one?
The one that we were just doing.
E? This one. So let me take this out of here. We were, for part E, we were rotating around.
Oh, never mind.
Yeah.
I took for that.
And then for part F, we were rotating around.
Yeah.
And that's why we had to go back to discs, because the discs allowed it to be dx. My favorite phrase.
And our radius is
Do you guys want to do another example of this? Or is there another thing you want to look at? Oh yeah, 7's a little bit freaky. Did anybody try 7 out? And you're all like, just get the damn thing and tell me whatever years later how much money you save. Take the antiderivative. So, the thing that the integral does for us is it changes a rate of change into an amount. Does that make sense? What's the, derivative. Another name for the derivative is slope, correct? Integral has two kind of names. It's the area, but what else is the integral? What is it really asking for? It's the first thing we do when we try to integrate something, we take the antiderivative, right? So, do you all agree that if they tell me that it's generating savings at this rate, if I did, that's a derivative, isn't it? That's a derivative of money. That's money per time. If I anti-differentiate that, I get an amount of money. Does that make sense? What do I get when I differentiate money with respect to time? I get money per year. So what do I get if I anti-differentiate money per year? I get money. And you're all like, "Ooh, is he telling us the secret to making money?" No. I'm not going to teach you how to count cards and take you to Vegas. Not this semester. No. So, if I take my derivative of money. Oh, the one little thing about this problem that I didn't mean to make weird. Do you see how I want the first t years? You guys see that? Let's make this the first x years. I think on the key I did it the other way around, but let me just do it this way. I can't have a t here and a t there. You can't do double duty. So if I want to know the first x years, what year am I starting at?
Year
0. Up to what year? X. Now integrate that. What is the integral of e to the x? Well, we'll do it in a definite order, so you're fine. So what's the integral of e to the 2x? Nope. Nope, that's the derivative. What's the integral? What's the derivative of e to the 2x? 2e to the 2x. So what's the integral of 2e to the 2x? E to the 2x. So what's the integral of half of that? Half of that. What's the integral of e to the 2x? E to the 2x divided by 2. Do you remember that divided by 2 kills the 2 that would come down? So, look. I'm trying to help you out with the problem here. If I have the integral of e to the ax, the answer cannot be e to the ax, because what's the derivative of e to the ax? E to the ax times, I need to kill the a, don't I? We must kill the a. I don't trust it. So I'm going to lay a trap for it. I'm going to put an over a. So when I take a derivative now and the a comes out for chain rule, it immediately dies. Yes? Does that make sense? Yes?
Is that for E, like always?
It's for every damn thing. So watch. There was a problem on the quiz that was like the integral of sine 3x. You know it's got to be negative cosine 3x, but that's wrong because that guy's derivative would have what come out? A 3. So what does it have to be over? Because you don't have a stupid 3 there, yeah? So what's this got to be divided by? 3. Yeah. What's the integral of x squared?
1/2 x.
Integral of x squared. Integral of x squared. X cubed over 3. Why do you put an over 3? To kill the 3 that would come down. Yes? When I say integral of x squared, is there a 3 in there? Is there a 3 in there? Integral of x squared, is there a 3 there? No. So if I think the answer to the integral of x squared is x cubed, I'm wrong, because what's the derivative of x cubed? 3x squared, yes? Okay, so I really want this to make sense. So this would be this. That's the correct answer. Yes? The integral of, what was I just talking about? I forgot. Oh yeah. Integral of x squared. It's not x cubed, is it? Why is it not x cubed? Because this guy's derivative would be 3x squared. Then there is no 3. So what must have been a part of this? An over 3. So some students feel like they're cheating, but this entire thing is working backwards. The x cubed was a guess. It was a really good guess. We know that's how it works. But it was a guess, and we're like, oh, I'm off by 3, so let me divide by 3. Bam. What's this guy's derivative now? What's this guy's derivative? The 3 would come down and die, and then the 3 would go to 2. Right? That's why I had to put the over 3 to kill the 3 that's coming down. So when do I have to do that? Any damn time that the inside, like if I'm doing this here, what do you got, Jeff? Write something. You can do it, buddy. No, I can't. What am I trying to do? Oh yeah, okay. Yes, cosecant squared 3x dx. What would this be? What do you take the derivative to get cosecant squared? What do you take the derivative to get secant squared? So what do you take the derivative to get cosecant squared? Close. Cos, negative. Why is that not the answer? Divide by 3, because you got to kill the 3 that would come out. Okay. What got me on that? Oh yeah, here, look. Bro. So what's the integral? So the 200 just comes to the right. Is that cool? I can take it out. What's the integral of e to the 0.1t? It's e to the 0.1t over 0.1. And then I evaluate it between 0 and x. What is 200 divided by 0.1? 2,000. 0, 0. Party over. Oops. Sorry. No. I lived through the 90s, kids, and we thought the world was going to end in the year 2000. So. Huh? Do you guys know about the Y2K problem?
Yeah, wasn't it that the computers were all gonna shut down?
All the people in the world said 2000's like 20 years away and shit. Let's just make computers not understand the first, instead of putting 1978, they just put a 78 and the computer just knew it meant 1978. So then everybody, as we got approached the year 2000, everybody, all the computer programmers are like, oh shit. Computer's not gonna have a clue what this shit. Missiles might fire, planes might fall out of the sky. So the night, New Year's Eve, 1999, I was at the waterfront, and we had a lit anchor that was dropping because we were stupid. Oh, look, we're like the Big Apple, but we ate with an anchor. And I was thinking it would have been so funny if right when it got to the midnight, it flickered the lights or something. But that would have been mass hysteria. Everybody was on edge, and you guys are like, man, you people are weird. Yeah. Sorry, that was the before times. That will not be on the test. So this is 2000, and now I just have to plug in an x, and I get this, yes? What do I get when I plug a 0 in?
Nothing.
No. Wrong. What's e to the 0?
Oh, 1.
1. So this is my amount of savings after X years.
Can we just leave it as a?
That's it. That represents the amount of money I will have saved. When X is 0, how much money will I have saved? 2,000 times 1 minus 2,000, I've saved nothing yet, of course, right? So then the question, a real life question is, if it costs $1,500 to install the damn thing, how long until I break even? Right? I am saving money over time, but it took an immediate outpouring of money to get the thing installed, yes? This is,
Set it equal to 15,000?
yeah, set equal to 1,500 and install. And that is a very pre-calculus problem.
Yeah, because you just take it over and then take it
Yeah, you add it and you divide and you take a natural log and blah, 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 yeah. So let me give you guys the answer key before I forget. 2 pages this time. by hand.
What's not gonna be the bread?
No. No.
I'm sure it's gonna
It's like at least two. Feels so good that people learned in here.
It's the one that says nominated
I just said.
It's up to you to put it together. Like an IKEA thing.
I did the back.
It's the IKEA purpose testing.
Yeah, it's 36.
I'll see all this with one test. Not unless it's a back. She'll take one of these problems, break it down, easier, like, oh,
I give you, get one.
see what the gear do, but it's long.
All right. By the way, the very, very last problem, number 9? How do you do number 9?
Make it negative first.
Oh, you
What's the first step?
said it equals
What? Is that in the right form to do f-top?
No,
What's wrong with this?
we have, instead of x squared at the top is at the bottom, we have to do the invert x squared.
Yep, so make it negative. Oh shit, now you're way too far in. Okay, and then I can do a derivative, right?
Yeah.
So d by dx of that shit is,
Do we input the x before?
that is the rule. You input the x squared, that's how you do it. But then what other rule says, hey,
But then chain rule will come to play.
and what is this? Yeah, sort of. Could be absolute value of x, but I would just leave it like that. Is that okay? And then you can bring the, let's just make this official.
We have to bring the negative over.
This would be, oh, there's a negative, that's right, I forgot. So it'd be negative 2x cubed, secant of the absolute value of x. Bodasical. Bodasical. Huh? Yeah, dude. You guys see that integral symbol and you expect it to be gross, and I don't blame you, but we are taking the derivative, which means we are just killing the integral symbol.
Doing F top
nothing happens.
is terrible tomorrow.
As long as it's a constant. And real quick, guys, remember when I did the concrete example of this earlier? We did at least 2 of them. When I plug a 5 into my antiderivative, will it not be a constant? So when I take a derivative, it's gonna die. So it does not matter. I could put a 58 trillion here, I could put a 0.97, I could put a negative pi. As long as it's a constant, it doesn't matter what it is. Yes.
This derivative would just be 0.
Yeah, 'cause if you took the integral and plugged it in, it would be constant, it would die no matter what.
Say it was x squared, x to x squared.
I was waiting for somebody. Okay. So what if I gave you, or like you had a problem, I don't know, in the homework maybe, where they asked you to take the derivative of this. Now, Do y'all understand? I'm about to ask you what is the worst part about this. The inside of it can never be the worst part because I'm just gonna write it and shove shit into it. So I don't care what I put on the inside of it. Can anyone see the worst part about it? You can't because you asked the first of the questions. Just sit there. Does anyone else see why this problem has some issues?
You have two X's.
I have two functions of x. Okay. Does everybody? Okay. If I wanted to get the area from A to B, couldn't I get the area from A to C and then add it to the area from C to B? If I wanted to get the area of this thing, couldn't I take the area of this plus the area of that? And that would give me the area of the whole thing. So the integral from A to B is equal to the integral of A to C plus the integral of C to B. I need you to understand that that is really just dumb.
How long is this table? Well, let me measure to here, and I'm going to add from here to there.
That's all that says, right? So I can go anywhere between two things, get the area up to that point, the area after that point, and then if I add them, I get the whole area. Nothing amazing. So that's what's going to help me here. I would go from natural log of x to some number that's in between these two. I don't have to be specific. Plus a to x squared. Bless you. So what I just did was, I went from natural log of x to a, and then from a to x squared. So did I end up going from natural log of x to x squared?
Yeah.
Yes, I did. So what's wrong with this one?
Kind of flip
You need to flip it.
Flip it, make it negative, and this one's beautiful. So then I can do the derivative of this plus the derivative of this. Yeah, I think there's at least one problem in the homework like that.
That's not that bad.
It really isn't. Yes.
Can you go over what like F talk two is? Just so
Oh, f talk 2 is
Just
the
like
thing we've been doing
integrals.
forever. It's antiderivative. So f talk 2
Just like get the antiderivative.
is officially. Jeff. So when you plug the limits into your antiderivative and take the difference, that's what you're doing. Yeah. So f top 2, you forget what it is because it's everything. It's just basically integration. F top 1 is the one you kind of remember it's f top 1 because it's the weird one. F top 2 is sort of like everywhere. It's just it. It's just everything.
And then you use F talk one when there's a variable in the.
When they want you to get the derivative of an integral function. Yes. So I would never use f top 1 if I want to get the integral.
So for f top 1 for this situation, you could just, it would first be f top 1 of x squared down, and then minus ln x f top.
For this?
Yeah.
Yeah, it would make this negative, and then you would plug a natural log of x in times 1 over x, and then you would plug an x squared in times 2x. Yeah. And add those together. Yeah. Yes. Which problem? I got my book, believe it or not. Section who to what? 5.5. 79. What the world? Oh my love. What's that little ghost thing going on? 79. Ooh! Look at that. Sorry, I'll calm down. That's the one in trouble, right? Okay. So what do you guys think about that? I don't like it. I mean, what could you try to do with it?
I'll say if you use sub the denominator.
Yeah, try and use some of the denominator, and then you quickly see something happen.
We're missing a variable.
Yeah, if you let u equal the bottom, du would be 1 over radical x, right? 1 over 2 radical x, right? And you're missing that, correct? this is I like this problem a lot. You would, Jeff. So here's the immediate thing I thought of when I saw this, and I'll show you this. This is weird. Has anyone tried this and figured out anything about it? You know, like I just sort of didn't write it down. Hoping you wouldn't notice. Okay. By the way, I will admit I had a teacher that if he just didn't write the problem down, he forgot he assigned it, so you wouldn't lose points for it. Sorry. I had a student say that to me. He said, "Yeah, one time this guy told me that you missed." I'm like, "I'm gonna grade the shit out of yours, just so you know." Yeah. Where do you go? Here it is. So here's the exceptionally weird kind of thing. I have no idea if this is probably not the only way to do this, but this is the immediate thing that came to mind. So if you do try to let u equal this, what do you get for du? Yeah, you get 1/2 x to the negative 1/2, yes? Which I can write as 1/2 rad x if I wanted to, yes? Is that cool? You guys with me? And you see that there you don't have that. And it's not a constant you're missing, it's a whole function of x you're missing, correct? Okay. Now I'm curious if this is going to go anywhere. Let's see. So here's my thought. What do you wish was down here? What do you wish was down here? A 2 rad x. No. What do you wish was right here in front of this? A 2 rad x, yes? You with me? Because then du would be in there, correct? So look what I'm going to do. I'm going to put 2 rad x on the top and 2 rad x on the bottom. Is that legal?
Yeah.
Of course it's legal, because I just multiply the inside by 1. I did not put a variable on the outside, because that's what I'm definitely not allowed to do. But inside, I can multiply the inside by 1, and 2 rad x over 2 rad x is 1. Except if x equals 0, but the integral is based on limiting functions, so it actually never gets to 0. So now let's see if this does anything for me. Do I see du now?
Yeah.
And just to really make sure you guys see it, couldn't I put a 1 here if I wanted to? So isn't this du? Yes? Yes? Okay. But don't I have this shit now?
Yeah.
But what was u again? So what is square root of x? U minus 1. So let me see. This, I don't know if this is going to go anywhere. Let's see. So I'm going to get, this would become 2u minus 2 over, yeah, this is going to work. Listen to me. U to the 4th du. There you go. That's crazy. Ooh, I like that problem. That is probably one of the more tricky problems. And I'm not even sure if that's like the main way to do it or whatever, and I don't care. Because now what can I do? Yeah, this over this minus this over this, and then it's an easy integral. Yes? Was that obvious? Was that an obvious thing to do? No. One reason I like that I gave that to you is just so you can play around with shit a little bit. But then if I show you how to do it, you start to realize how much more there is to integration than we're able to do in this class. And that's why Calc 2, the entire first chapter is just, let's expand the integrals we could do. Let's talk about other methods we could use. Which probably, I don't know if that's making anybody excited about Calc 2. Probably not, I'm sorry. Is that okay? Who asked that question? Is that okay? Yeah, that one is hard to give like a hint with. But you see, what was my motivating factor? And when you asked the question, I didn't remember doing it. So part of me up here, here's a little insight, a little behind the scenes. I was standing over here and I walked over and I was like, all right, and I'm thinking to myself, I don't have a clue. I don't know what to do. I'm standing here, I'm like, I don't know. And then I'm like, oh shit. Yes? Okay, sorry. I'm really happy it actually worked. Yes?
But then, so then from there you go, you like change.
2u over u to the 4th and make it 2 over u cubed. 2u to the negative 3,
Oh, yeah.
minus 2 over u to the 4, 2u to the negative 4.
And then you get the.
Easy integral. So when the bottom is a single term, tears of joy. Because then you can just break everything up, and then it should be a lot easier to integrate.
Because then we
Huh?
it's easier for me.
Yeah, because then it basically boils down to x to the n. Each piece, bum, 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 yeah. Nobody ever really believes. I brought nothing. I'm just here. So if you guys have questions, I'll do some. If you don't, I'm just gonna stay here. Huh?
Maybe we can take a picture of that paper.
Yeah.
My love.
There.
Thank you.
Now I got this song in my head, damn it. You guys wouldn't know what movie I'm talking about? The picture of the person with the clay?
Oh, my love, my darling.
Ghost. What's her name? Screw it. That's so old, Patrick Swayze. Demi Moore. See you.
Where's the like train platform?
Always in the same place.
And is this like somewhat right for the quiz scriptures?
What was this one?
That's
Doesn't look quite right. Let's see what happens.
Oh, come on now.
oh 6. Yeah.
Okay.